So we'll be looking at rational expressions. It's important to understand that rational expressions have some restrictions along with them. But a rational expression is just the ratio of two polynomials. It can be written in the form of px over qx, where px and qx are polynomials. But really importantly, qx must not be equal to 0. So, for example, I have given you here in this line 5 examples of polynomial expressions. Well, we notice among the numerator and the denominators are both polynomials. So the first one is clearly a rational expression. The second one is a little bit more difficult to spot out, simply because some may argue that the numerator is not a rational expression because the numerator is not a polynomial. But regardless of your view, whether one is a polynomial or not, 1 over x is defined as a rational expression. Same with the rest. These are all rational expressions because the numerator and the denominator are both polynomials. So perhaps let's go on to non-permissible values. So these are called non-permissible values, or MPVs, sometimes noted MPVs. But I also like to call them restrictions. So it's important to identify and exclude the values of x which make our denominator 0. Why? And it's a really important fact that you must never divide by 0. It's impossible. So for example, 4 divided by 0 is, well, hopefully you hit a roadblock and said, well, it's undefined. You can't divide by 0. So these are called non-permissible values or restrictions, the values of x that make it 0. So allow me to start with our first example here. For each rational expression, identify the non-permissible values. Well, the non-permissible values are those values of x that make our denominator 0. So let's take a look at our denominator. For what value of x is the denominator 0? Don't overthink this one. Really, it's just when x is equal to 0. So we write our non-permissible values that x cannot be equal to 0. So let's go on to the second example. So the second example is like this. What is 1 over 2x, right? So what are the restrictions here? So we just look at the denominator. So it's whenever 2x is equal to 0. So when is 2x equal to 0? When x is equal to 0. And if that's not intuitive to you, you can literally write, when is 2x equal to 0? Well, 2x is equal to 0 when x, so if I divide both sides by 2, when x is equal to 0. So x cannot be equal to 0, in this case 2. Let's move on for the third example. Now this one's a little bit different. If you notice, we have 2 factors in the bottom. So when is that denominator equal to 0? Well, I'm just going to talk about the zero product property just briefly. And it's something I think we all know and we've all come across. And if you think about it, it makes sense. And I'm just going to say A times B is equal to 0 if and only if A is equal to 0 or B is equal to 0. By the way, A and B are factors. So if you know that one factor is equal to 0, that means that the product is going to be equal to 0. So for example, so if A times B is equal to 0, if you know the product is equal to 0, then you know one of the numbers or one of the factors has to be equal to 0. And if one of the factors, A or B, is equal to 0, then the product is equal to 0. So this is called the zero product property. So I'm just going to take a look at triangle times square is equal to 0. So when is triangle times square equal to 0? That's a great question. And it's actually under only 2 circumstances. Its triangle has to be equal to 0, or square has to be equal to 0. There are no other cases where 2 numbers or 2 factors multiply together to give you 0. Now, instead of numbers, I'm going to use the word factors. So let's take a look, revisit this. When is this denominator equal to 0? Well, I have the factor x minus 2 and I have the factor x plus 3. So when is this equal to 0? Well, this is equal to 0 when this first factor is equal to 0, or when the second factor, is equal to 0. And now we have two linear equations. So when is x minus 2 equal to 0? Well, if you put 2 over to the other side, this is equal to 2. Now let's look at that second factor. When is x plus 3 equal to 0? Now, if you subtract 3 to both sides, our denominator is equal to 0 exactly when x is equal to 2 and x is equal to negative 3. So I have to write the negative of that. So x cannot be equal to positive 2 or negative 3. So those are my restrictions. And maybe you could spot this out initially. If you give this good hard thought, you're like, when is the bottom equal to 0? Well, when that first factor is equal to 0. And that would be, when is that first factor equal to 0? When x is 2. When is the second factor equal to 0? When x is equal to negative 3. Similarly, let's go on to this next example. So my restrictions, my non-permissible values, this is the price to pay to even get into the conversation of rational expressions. That denominator is equal to 0 when x minus 4 is equal to 0, or when x plus 1 is equal to 0, using the zero product property. So I have two linear equations. So x is equal to 4 and x is equal to, I wrote that incorrectly, negative 1. So I have to include this. This is really important. X cannot be negative 1, comma 4. I'm going to highlight that because it's really important. Non-permissible values. So when we take a look at finding non-permissible values, what we should maybe do, keys for finding non-permissible values. Well, so far, is factor the denominator. That is incredibly important because if you notice, I've been using the factor word a lot. So the zero product property is expressed as factors. Now, let me consider this next example. What are my non-permissible values here? Now, mental math sort of taps out here. When is that denominator equal to 0? I have no idea. You could take a guess, or you could follow the key to find non-permissible values and see if it hits you. So let's factor the bottom. So if I factor the bottom, it appears like this, I believe. Hey, that is the exact same denominator as what we have before. Isn't that interesting? So what we get is x cannot be equal to 4 or negative 1. Last but not least, I'm going to find my non-permissible value. So these are just finding my non-permissible value or my restrictions. Look at that denominator. 4x squared plus 8x plus 4. We cannot allow this to be 0. So naturally, what I'm going to do is I'm going to find out exactly when it's going to be equal to 0. But my key here is factor the denominator. So if you want, you could take this work to the side. And I'm just going to factor that. If you want to press pause and do it yourself, that would be awesome. There. What I notice is that I can factor out 4. When I can continue to factor. So my expression, or the denominator, is equal to 0 exactly under 3 cases. One of them's nonsensical. When 4 is equal to 0. Well, 4 is never equal to 0, so we just can exclude that. Now, when x plus 1 is equal to 0, or when x plus 1 is equal to 0 for the other factor. If you notice, those are the same factors. This is true exactly when x is equal to -1. So my restriction here is x cannot be equal to -1. So I feel like I can write more keys to find my non-permissible values. Factor the denominator. Determine the values of x that make each factor 0. That's what I've been doing all along. So I take a factor and I ask myself, what is it, or what value of x makes this 0? And then the third one is exclude this x value.